This is Engineer Faisal Ijaz. Hope you will be fine. In this channel, I prepared detailed lectures for chemical engineers and also for associate engineers. In this channel, you will find playlists of different engineering subjects which will help you in your study, in your interviews, and also during your professional industrial life. So subscribe my channel for more videos. Hope you will be fine. This is Engineer Faisal Ijaz. Today I will present a topic, steam turbine, and I will discuss the following contents: definition of steam turbine, working principle of steam turbine, and types of steam turbine, in which I will discuss impulse steam turbine and reaction steam turbine. According to its definition, a steam turbine converts heat into mechanical work. It's mean the function of steam turbine is to convert thermal energy of steam into electricity. So these steam turbines are heat engine machines, and these are available in different sizes from little to massive. These points are about benefits of steam turbine. The first is these turbines have a big range of power capacities. The second is turbines have several benefits over steam engines. The third is high thermal efficiency will be meeting with steam turbines. And the fourth one is there is not any rubbing component, so its lubrication process is very easy. And the fifth one is this is best for jumbo power plants. Working principle of steam turbines. The principle of steam turbine is very simple. This principle run around only a single word, steam. So turbine work due to dynamic action of steam. So you know well that steam is available in different types. So you must remember that here superheated steam is used for turbine. So that superheated steam coming from the nozzles, and it attacks on the rotating blades. These blades are fitted on a disc, and that disc mounted on a shaft. To run blades, dynamic pressure is required, and that high pressure created due to high speed of steam. So after it, blades and shaft rotate in same direction, and that rotation depends on the following factors. The first one is operating pressure, size, construction, and lots of alternative parameters. Now I will proceed towards the types of steam turbine. So there are two basic varieties of steam turbine. The first one is impulse steam turbine, and the second one is reaction steam turbine. So the main distinction in these turbines depend on the way of steam expansion. Important highlights of impulse steam turbine. According to first, when the steam passes through the fixed nozzle, it expands fully, but its pressure remains constant, and its blades have symmetrical design. According to third, the speed of steam is high in impulse steam turbine, so the speed of these turbine is also high. Impulse steam turbine, you know the main difference in steam turbine types is steam expansion. So in this type, high speed steam coming from a fixed nozzle, and in the next step that steam strike with the blades mounted on the outer boundary of a rotor. Here you can see the different examples of impulse steam turbine, in which Brown, Curtis turbine, and Ratio turbines are included. Modern plants use both types of steam turbines, impulse steam turbine and reaction steam turbine, in the same unit. The second type is reaction steam turbine. So as the steam passes over the blades, it expands and it moves the blades. So here in this turbine, pressure drop produce. So it produced due to each of moving blades and also due to fixed blades. As according to its construction, reaction steam turbine is constructed of two types of blades. One rows of fixed blade and the second rows of moving blades. The fixed blade act as a nozzle. Now we will talk about pressure drop concept in both types of steam turbines. So reaction steam turbines are completely different from impulse steam turbine due to its construction, as reaction steam turbines composed of moving blades and fixed blades acts as a nozzle. So due to these both blades, high pressure drop is developed. But in impulse steam turbine, the pressure drop per stage is lower than reaction steam turbine. From both types of steam turbines, the reaction steam turbines are very efficient. So the example of this turbine is Poisson turbine. So according to its construction, reaction steam turbine required double quantity of blade rows than impulse steam turbine. So due to this construction, the reaction steam turbines are much longer and heavier in size. Important reaction turbine highlights. According to first point, impulsive forces strikes the blades. You know well that steam strike on the blades, and these blades are mounted on the rotor. In the next step, the pressure cannot expand totally like in impulsive steam turbines. Here in this case, pressure cannot expand totally. Only the steam passes through the nozzles and rest of the steam through rotor blades, so it's partially expand. According to third point, the design of blade is asymmetrical. According to fourth point, because the steam speed is lower in reaction turbines, so the speed of these turbines is lower than impulse steam turbine. So according to fifth point, to develop constant power, it needs additional stages in its design. According to sixth point, the blade potency curve is lower than impulse steam turbines.